Now, what we're going to talk about today is something called a WiiMote. That's what it looks like. They're now about 20 years old, maybe 25 years old. They came as part of the Wii game system. There's the Wii game system there. The actual console itself is only about 7 inches wide and about 10 inches long, maybe an inch thick. And you get a couple of these Wii remotes. There they are over to the left. Each one's about 6 inches long by an inch by an inch. And it comes with that nunchuck thing, which plugs into the bottom of it. You very often see, if I just go back a couple of slides, that one there is what it looks like, but you'll very often see them with this rubber hood round about them and the lanyard attached. The reason for that is that when you're playing with one of these, if you're using it with a games console, then you spend a lot of your time swinging it about like a tennis racket or a golf club or whatever. And that's to stop you, when you're destroying lampshades and vases and windows and stuff, that's to stop you destroying the Wii remote at the same time. It's got that rubber bumper on it. The actual remote, this has got nothing to do with the Wii console. The remote contains a 3-axis accelerometer, a 4-shot infrared camera, a camera that looks in the infrared, not at visible light, and it uses AI to track the 4 highest visible spots of infrared light. It also contains 11 switches, 4 light emitting diodes, a joystick, a rumble motor, one of these little rumbly motors like you have in your mobile phone for giving what they call haptic feedback, so that you can feel when you're touching something, the thing in your hand shakes. A speaker, a Bluetooth connection, and an I2C connection coming out the back of it that you use to connect this nunchuck thing. The nunchuck itself also contains a 3-axis accelerometer, so it knows where it is in space, plus another couple of switches, plus a joystick, and it connects to the main unit via a wee cable with I2C on it. The whole thing runs off 2 AA batteries, and it'll last for about a fortnight on those 2 AA batteries. You can buy them from our friends in the East. They'll sell you one for between £5 and £15, call it a tenner, depends on what you want to buy, whether you want to buy a coloured one or a plain one, whether you want extras built in, whether you want the rubber hood, whether you want the nunchuck. There's all sorts of options. Or if you want to buy one closer to home, Amazon will sell you one somewhere between £10 and £20, again depending on what options you're taking up and stuff like that. But as I say, these have been about for 20 years now, more than 20 years. So you can also get them in charity shops, in cash converters. You can pick one of these up in the pawn for a couple of £. Games shops, the people that supply games in the high street, if they're still there, there's 1 or 2 of them left and they'll sell you one of these. And even if it depends on your local Coop, but if your local Coop has got a pile of electronics, old games and stuff lying about, you could pick one of these up there, probably for the picking up of it, or maybe for the price of a pint. So I'm about to show you a couple of quick demos. These demos you do not need to own a Wii console for. All you need is the handheld remote. You don't need to have ever owned a Wii console, had one in your house. You only need a single remote. So I'm going to push on and let you see these. Hopefully you'll find them interesting.
Hi, my name is Johnny Lee, and I'm going to show you how to create a cheap electronic whiteboard system using the Nintendo Wii Remote. Now, just like my other video on tracking your fingers using the WiiMote, this project is also only going to use the infrared camera built into the front of each controller. Now, this camera is sensitive only to sources of infrared light, which is why it can track things like the Nintendo sensor bar, light bulbs, or candles. So if we want to track pens on an electronic whiteboard, all we have to do is create pens that emit infrared light. The light pen is composed of an infrared LED, a push button switch, and a connection to a power supply, which could easily be a battery. When I push the button, the LED turns on. This is basically an LED flashlight in a pen form factor. If you want to make one for yourself, you just start off with a shell from a normal ink pen and then glue in your components. Now behind me is a projected image of my computer. Now if I want to interact with that image with my light pens, I have to make sure that the Wii remote can always see the tip of the pen. To do this, I have to put the Wiimote off to the side so I don't block its view when I'm in front of the projected image. I've made this little stand for my Wiimote, but you can use any material you have around the house to prop it up in the right orientation. Now when I put it on the shelf, I have to make sure it's pointed at the screen so we can see the whole area. Now it's important to remember that the Wiimote has a field of view about 45 degrees. So make sure you're back far enough to see the whole screen, but not too far back, because otherwise you'll lose tracking resolution. Once I connect the Wiimote to the computer over Bluetooth, I can do a standard 4-point touch calibration like they do on most electronic whiteboards. What this does is it maps the camera coordinates to the projector coordinates, and now the cursor will show up wherever my pen is, and I can simulate a mouse and draw in a drawing program or manipulate my windows. One nice thing about using the Wiimote to do this is any surface I can project onto, I can basically turn into an interactive whiteboard. Now what I have here is a projector mounted onto a tripod, which is kind of a generally useful thing to do anyway. And it's now pointing at this tabletop. And the Wiimote is actually attached to the projector, so we can have this top-down view of this display. Again, after I do the 4-point touch calibration, I can now use my pen just like a mouse, and I can interact with my table like it's a multi-$1,000 interactive whiteboard. Additionally, because the Wii remote can track up to 4 points simultaneously, if we use 2 pens, this is actually a multi-touch interactive system. If you don't happen to have a projector, you can still use the same technique with a liquid crystal display. We simply mount the Wii remote, point it at our display, and then do our 4-point touch calibration. Now we can essentially turn any liquid crystal display into a multi-touch tablet surface. So that's how, with the Nintendo Wii remote and some infrared LED light pens, you can create your own really low-cost multi-touch interactive whiteboard system or multi-touch tablet PC. Now, in truth, the tracking resolution you're going to get off the camera is not going to be as good as one of the commercial products, but it's pretty good and it's much, much cheaper. So I hope you've enjoyed this video, and if you'd like to try out the software, you can go to my website and download a copy and try it out for yourself. Thanks for watching.
Right, there's more.
Hi, my name is Johnny Lee, and in this video I'm going to show you how to perform head tracking and create desktop virtual reality displays using the Nintendo Wii remote. Now first, what do I mean by a desktop VR display? Well, you think about most computer screens, they're typically used to display a flat image, a little bit like this picture in this picture frame. Even if the picture is of something 3D, like a video game, the picture is still flat. So it doesn't change depending on what angle you view the screen at. A desktop VR display, however, is a little bit like taking the picture out of the picture frame and then just having the frame. Now the scene actually changes depending on what angle I view the screen at. So this essentially becomes a portal or a little window into another room. Now to do this, the computer needs to know the location of your head relative to the screen, and this is called head tracking. Now to perform head tracking, we're going to be using the Wii remote and the sensor bar, but we're actually going to be using them backwards. We're going to put the Wii remote next to the TV and actually move the sensor bar instead. The Wii remote actually contains an infrared camera, and the sensor bar is simply 2 sources of infrared light. When the camera sees the 2 dots of light, it's going to give an approximate location of my head horizontally, vertically, and in distance from the screen. Okay, the tricky part is now we're going to have to find some way to mount the sensor bar onto our head. One common trick is to get a baseball cap and then mount the hardware to the cap. And this is definitely going to work, but it's a little bit goofy. So instead, some hardware stores sell these safety glasses with LEDs built in on the side meant to be used as headlamps. Now, if you replace the LEDs with infrared ones, you essentially get your head-mounted sensor bar and a nice, sporty safety goggle form factor. Once we've created our head-mounted sensor bar and I've connected my WiiRemote to my PC, we're ready to do some head tracking. Behind me is a demo program of a 3D room with some targets floating in it. Now, because the effect only works for the person wearing the sensor bar, I'm going to have to show you the effect through a moving camera. Now, to do this, I'm literally just going to hold the sensor bar at the base of the camera and move it around. Just a quick note, to power the sensor bar, I simply turn on my Wii after I've connected my WiiRemote to my PC. First, I'm going to show you what it looks like without head tracking, which is what displays normally look like. You can see that although it's a picture of a 3D room, the image looks very two-dimensional and bound to the surface of the TV. Now, with head tracking turned on, the TV actually looks like the entrance to a real room. Just like in real life, by moving our head around, we can look behind objects. And if you look really closely, some targets actually appear to be floating out in front of the screen, reaching into the real world. If we get closer to the screen, we get closer to the objects, and we can even get behind the ones floating in front of the screen. As I pull the camera back, keep an eye on the frontmost target. Head tracking provides the illusion that the target is actually floating directly above the laptop screen, far in front of the TV. Now, using this picture of a football stadium, if you move right, you can see more of the field. If you move left, you can see more of the stands. And if you get closer to the screen, you see more of everything, just like a real window. If I use my IR glasses and keep the sensor bar on the TV, I can use a second WiiRemote to point and shoot like any Wii game while also doing head tracking. So now ducking and shifting your body is actually meaningful to a game. You can also see now how the perspective is incorrect if you are not the one wearing glasses. So head tracking for VR displays is only going to work for one person at a time. But for that one person, the 3D experience is going to be far more realistic and immersive than anything else we see in homes today. So if you're watching this and you're a Nintendo Wii game developer, I want to see some games. Anyway, as usual, you can visit my website to download this software and find out more information about my other WiiMote projects. Thanks for watching.
First of all, let me point out that both of those videos are 15 years old now. There have been huge strides made forward since then. There's lots of Wii games that now use that sort of technology. There's lots of other things have moved on. Also, Johnny Lee Chung, the guy that did that presentation, has got about 3 or 4 other Wii remote videos, including tracking your hands in space and all sorts of other stuff. I recommend digging him out on YouTube and going and having a look at his videos from 15 years ago. If you're interested in doing that, you can still buy safety glasses with the little LED lights on. Infrared LEDs come from old remotes. Television remote controls and hi-fi remote controls have all got a little red LED in the front of them. I did this, as I say, well over a decade ago. And what I did was I used a highlighting pen with 2 AAA batteries inside it, and the remote control LED on the front of it, and a little tactile switch. And at that time, we had just moved in to a new building in the college. And as part of the budget cuts that always come with a new building, we'd been given projectors, but we hadn't been given smart boards. And so I'm using the projector and managing to stick my laptop into it and leave the Wii remote lying at the front of the class. I could do that stuff using the highlighter out my pocket. Not only did the students think it was witchery, some of the teachers thought I was a wizard as well, just from being able to pull this trick off. Really, really clever, and there's lots and lots of things you can do with it. And those are just the start of this. It all relies on Bluetooth. Bluetooth is now an elderly standard. It was first talked about by Ericsson in 1989. We're now at Bluetooth 5. And you'll also hear the expression BLE, which is Bluetooth Low Energy, which is an extension of Bluetooth that allows it to work with little energy and over longer distances. Bluetooth is used for personal area networks. That's important. I'll explain about that in a wee minute. Now, these are things like speakers and microphones and printers and keyboards and mouses and all the stuff that hangs round about your computer or round about your workstation. And it's now standard. If you buy a new laptop or a tablet or a phone, it's probably got Bluetooth of some flavour installed in it. If you get a newer Raspberry Pi that's version 3B or later, then that's got Bluetooth built into it as well. How it works is that Bluetooth devices pair with each other. A Bluetooth controller and a Bluetooth device speak to each other, and that's a pairing. A device is a thing like a mouse or a keyboard or a WiiRemote, can only be paired with one controller, or rather one controller at a time. I can use my WiiRemote with my computer here, and then I can wander through into another part of the house where there's another computer, and I can use the same WiiRemote with that computer. But when I start using it with that computer, it stops being paired with this computer. One controller can pair with lots of devices. There are extensions that will allow Bluetooth devices to pair to each other. So, for example, a mobile phone, which is essentially a controller, will also act as a device when it connects to your computer. Pairing itself, you may actually have to enter a numeric code in both of them, or one of the devices gives you a 4-digit number that you've got to enter into the other device. Or you might have to press certain buttons in both devices at the same time, or sometimes you don't have to do anything. Just the very fact that they're close enough, they will pair. Once a device has been paired, it will be remembered by that machine. So if I pair a WiiRemote with this computer, then from now on, this computer is aware of that WiiRemote. It uses the MAC address, exactly the same as the Wi-Fi MAC address, partially the manufacturer's code number and then partially serial number. And it uses a MAC address exactly the same way. And like Wi-Fi, it operates in the same frequency range, right in the hydrogen line there. And exactly the same way as Wi-Fi, the range is a variable. Depends on how many walls and how many people and how much liquid to absorb energy there is. But you'll certainly get 5 meters out at every time, and I've had up to 100 meters out of it, depending on the electronics that you're using. Speaking of the electronics that you're using, if you don't have Bluetooth built into your machine, if it's not a laptop or a tablet that has Bluetooth built in, then you can buy a Bluetooth dongle. There's one of the better ones for the grand princely sum of £7 from Amazon. Very simple wee thing. You plug it into a USB. As you can see, 2/3 of the actual device is USB plug, and all the electronics lives in the third of the device. You plug that into your computer, and the Bluetooth symbol appears. You see the Bluetooth symbol at the bottom there of the licorice all sorts that have appeared on my taskbar. Next to the Bluetooth symbol in that list, by the way, is a black thing that represents my WiiRemote, because my WiiRemote's already connected by Bluetooth to this computer. There's the Bluetooth symbol. Now, you would think that when you press that and a menu pops up, that what you would do would be add a Bluetooth device to add a WiiRemote. And that would be the most obvious solution, is to add a Bluetooth device, but it doesn't work that way. Remember earlier I said Bluetooth is used for personal area networks. Well, this is a personal area network situation. So what you have to do is tell it you want to join a personal area network, and up pops this, and you can tell it you want to select the Nintendo RVL controller, and it will install it. From then on, down in your licorice all sorts in your notification area of your computer, you will suddenly have the Nintendo device popping up. But you will also have a couple of other things because of this personal area network. You'll have that connect option that wasn't there before. And you'll have sharing with nearby devices, so you can share data and information with other devices that are in there within the range of your personal area network. So that's Bluetooth and how to get your Wii Remote connected to Bluetooth. There's a ton of support for the Wii Remote. Microsoft.NET and all its languages all support it. Python, Java, Rust, Arduino, Raspberry Pi, you name it, there's Wii Remote support. Because these things are 20 years old, everybody's had a play with it. One of the standard toys is this. And I took this shot this morning. When you switch the Wii Remote on, up to the top left there, you'll see WiiMote Excel. That's the accelerometer. That tells me where it is what direction it's pointing in space. And then next to it, there's the 4 IR targets that it can see. Mine's was popping out, I was pointing the Wii Remote out the window at the sunlight, and it picked up 4 sources of infrared and tracked them for me. And there's not an awful lot of infrared light in Prestwick on a Sunday morning. Plus there's controls there for all the LEDs and all the switches and all that good stuff. And then all these other things, guitars and motion pluses and joysticks and all that are things that you can plug in to extend the Wii Remote. So you can have all these other inputs and outputs as well. Now, the WiiMote is on. It's lying on my desk here, right? And you can see the acceleration thing flicking. That's the accelerometers working. As I speak, and every wee motion in this room causes the accelerometer to move. As I pick it up, you'll see them changing. But the infrared targets, it's only spotted one infrared target so far, which will be a reflection of something. If I pick the controller up and point it out the window, suddenly it's seeing infrared from my environment. And if you look at the black screen at the bottom, you'll see that the 4 most prominent targets are being picked up. There's 4 little dots there, and those are the 4 brightest targets. And that's how it does its thing. It picks the 4 brightest spots in the sky, or the 4 brightest spots that you're looking at. And an infrared LED off the front of the remote is much, much brighter than anything that I can get round about here. And while I'm at it, if I press any of the buttons or do that, you can see that I get that. And what I'll do is I'll hold my Wii Remote to the microphone and press the rumble. Like you see all of that stuff. And this all works. It just works out of the box. It's really amazing. But if you see where it says IR at the top of the screen and they're all moving, as I wave the remote about, I'll set the remote steady. There's 2 sets of numbers come out there. At the top, it gives you how far across the camera it is from 0 to 1, and how high up the camera is from 0 to 1. And then the bottom, you get the same positions scaled from 0 to 1024 and from 0 to 768. So you can either do it in floating point numbers from 0 to 1, or you can have a resolution of 1024th of 45 degrees, whatever that is. 45,000th of a degree. And as you can see, I'm literally pointing out the window at the sky at the minute, and it's finding 4 little dots. And if you'll zoom in really close to that black square at the bottom, you'll see the 4 little dots tracking as I move the thing across. And these will be reflections off of people's windows and off of metal objects and stuff that have got IR polarization on them. And you can see I'm moving this up and down a centimetre, and it tracks quite comfortably up and down a centimetre. And that's for a building that's 30 meters away. So the accuracy is there. It's not as accurate as a professional high resolution, 4K camera or something, with IR filters taken off and all sorts of clever governments in the back, but it doesn't cost nearly as much. It costs you a tenner, whereas that camera costs you an arm and a leg and a kidney. This is why I can talk about this subject, because I actually have one of these and I use it regularly. In fact, daily. I do a lot of programming, as anybody that knows me on here will know. And I program in Visual Studio, VS Code, Spider and Anaconda for Python, Jupyter notebooks, MATLAB and Octave notebooks, Eclipse, and then in the microprocessor side, MPLAB, MPLAB-X, Atmel Studio, JAL Edit, Platform IO, Cube for the STM32s, Arduinos, all sorts of things. And when you're programming, there's stuff that you do all the time, particularly while you're testing. You want to put in a breakpoint or take out a breakpoint. You want to make the program start. You want to restart the program. You want to step through the program. And all of these programming products all do this. But it's always different. It's always Shift F7 on this one, but it's F11 on that one. And it's Control F10 on that one to do the same thing. So what I did was wrote this tiny little program, WiiWand, which when you switch it on, it notices what programs you're running. And then it goes and in its own little database, it works out what button presses you have recorded to each of the buttons on the WiiRemote for each program. So you pull down, on the left there, you see it, I've pulled it down for MPLAB, and there's what the various buttons are for MPLAB. And on the right, I now use it with Zoom as well. And I can go to the next camera across, or I can share the screen, or I can mute the thing, or all that stuff just by holding the WiiRemote. So I don't have to be near the computer keyboard to do this stuff. It doesn't have to be a computer. If you are using Arduinos, then there's this fella. Your normal Arduino has a USB socket on it. And that USB socket is a USB device. So the Arduino is a USB device that you plug into a computer. Right? The device gets plugged into the controller. This USB host shield, which you can buy practically anywhere, I think will cost you about 10 or 12 pounds, gives you a USB host on your Arduino. So now you can plug in a keyboard or a mouse or storage or any of that stuff to your Arduino. And if you notice, it's got riser sockets on it as well. So what you do is you put that onto the Arduino to give you this external control, and then you put whatever you were going to plug onto the Arduino anyway on top of it. So it gives you an extra layer of control. And if you go to the examples that come with the host shield, there's dozens and dozens and dozens of examples of things that you can do with the host shield, including a whole section of Bluetooth examples. If you plug the little Bluetooth dongle into your host shield, then you get all these other things that you can do, including half a dozen WiiRemote examples. So that's half a dozen different things that you can do with a WiiRemote on the Arduino. Right? And again, no computer involved in this. At this point, it's just an Arduino connected to some electronics, and I'm controlling it with this. This gives me all the buttons and all the LEDs that I need without having to put them, having to wire them to the Arduino. The Raspberry Pi, as I say, if it's a Raspberry Pi better than B+, Model 3 B+, then up at the top left-hand corner there, you will notice a little tin box, a tin shield with a raspberry stamped on it. And that's the Bluetooth I/O corner of the credit card shaped board. And it's Bluetooth version 4.2, so it's a fairly recent Bluetooth, so it's really well connected. It'll do lots of stuff. It's very easy. It wakes up out of the box. If you put Raspberry IO into your Raspberry Pi, it'll work with it. If you happen to have an older Raspberry Pi, then there's nothing to stop you plugging the little USB dongle into one of those 4 USB ports over to the right-hand side. It will enumerate it, it will recognise it as a Bluetooth controller, and it will use the Bluetooth, and you can then use your WiiRemote with a Raspberry Pi. The big point of using a WiiRemote with a Raspberry Pi is that on a Raspberry Pi you can run GMRI. GMRI is the Java Model Railroad Interface, and probably everybody that's on this call will already know about GMRI. While we're talking about it, every time you mention GMRI, somebody says, but what about RockRail? Well, what about RockRail? RockRail doesn't do this. There's no WiiRemote stuff on RockRail. I've been and checked. Right, you could use my little wee wand trick on RockRail if you wanted, but there's nothing built in to RockRail. GMRI currently has 2 WiiMote ginstruments. A ginstrument is a Java instrument for GMRI, and they've given them wacky file names. They're called WiiMote Throttle and WiiMote Throttle 2. And there's the code that's inside both of the WiiMote throttles so that you can see the difference. The one on the left is WiiMote Throttle, and the one on the right is WiiMote Throttle 2. And you can see the controls left and right, up and down, plus and minus, A and B, and so on. On the WiiMote Throttle, then the 1 and 2 keys let you go through 4 standard speeds: cruising speed, top speed, slow speed, and stop. And you can just do that by pressing the 2 buttons on your WiiMote to control the train to standard speeds. You can also accelerate or decelerate to other speeds, obviously. But if you just want to have 4 standard speeds, it'll do that. The other one doesn't have that option, the 4 standard speeds, but instead it gives you 2 functions or 4 functions. And that can be things like sound and, you know, if you've got local decoupling or whatever built onto the local, it'll do that, whereas the other one won't. So you've got choices. Now, I've got to admit, I'm not a fan of GMRI. As a piece of software, I'm sure it's perfectly good for what it does, but by God, is it a bugger to use. So let's just talk about how you install these on GMRI. First of all, what it tells you do to install these in GMRI is dead simple. You drag the ginstrument onto the throttle controller. So here we go. On the right-hand panel, I've located the ginstruments. They live in ginstrument throttle, whatever it's called, can't remember. But if you do a search on your machine for WiiMote Throttle, you will find it. And over there, I have the Decoder Pro. I'm going to select a new throttle. There's my new throttle. And then I select one of my WiiMote control gins, and I drag and drop it on top of there. And if you've done everything right, nothing happens. But fortunately, I hadn't done everything right, and so something happened. And so I knew that I hadn't done everything right. I get this, which is programmer speak, right? And it's gibberish if you're here for modelling or for model railways. Required dependencies. What in the name of the wee man is he talking about? What that says is that a piece of Java code needs to be installed. Turns out it's not hard to do. What you do is you select that piece of text there with your mouse, and then you right mouse copy, and you go up to your browser and you paste it into the target bar on the browser, And when you press return, nothing happens. Do you see a pattern emerging with this nothing happens nonsense? It's doing my head in. I discovered that you have to then close Decoder Pro, close JMRI, and restart it. Before I restart it though, what I'm going to do is I'm going to go to the downloads folder on my computer. And I find there that I have downloaded, by going to the browser and dropping that thing into the browser, I downloaded this jar file. It didn't tell me it was downloading it. There was no indication, there was no dialogue popped up, but I did it. So now if I select that jar file, and over to the right, the JMRI lib directory. So what I do is I take the jar file and I drag and drop it over into the JMRI lib directory. And then nothing happens. And then we have to restart Decoder Pro. And now if I go back to what I was doing 5 minutes ago, and I go back to my WiiMote throttle and drag it over and drop it on top of the throttle controller, and you'll never guess what happens. Nothing happens. But if I then restart Decoder Pro, I suddenly have a throttle, and that throttle is controlled by my Wii remote. Now I've kind of laboured that. That lack of user confirmation, I really find irritating. I've taught user interface design, and I find that really gives me the irrits. People should know that they've done something, or that they've done something and it's failed, or that they've not done something. And this, you know, you're just left guessing half the time. You have to have a play with it. Also, while I'm here, JMRI will also do this sort of trick with, if you've got a PS3 handset lying about, or an Xbox handset lying about, or any one of these dozen game controllers or game pads or whatever, then you can use them as a controller, as a throttle in JMRI. From what I can understand, you can even use it at the same time as another controller. So it means you can leave controllers lying dotted round about the layout, which might be of interest. So moving on to another subject. A couple of weeks ago, there was some chit chat on the forums about people wanting to monitor a layout by putting a camera over it. And the plan, the theory was, we put a video camera, a full motion camera above the layout, and we use that to watch the rolling stock going round about. And we then use OpenCV. OpenCV is a library for doing computer vision. Now, I've used OpenCV to do number plate recognition and facial recognition, and it's hard sums. It takes a great big processor and a ton of cycles to do stuff like that. And when this was pointed out to the people that were talking about this, they said, well, we'll mask it. We'll put only certain boxes where things can change, and sort of draw totties on a mask and see things coming in and out of there. And then you have to train your AI to recognize the masks, and you have to do all sorts of stuff. And the light in the morning is different to the light in the afternoon, is different to the light in the evening, is different to lights when it's dark. And all of these mean it has to be retrained under those circumstances. And you need a ton of processing. And this was all going on. And I'm reading the daily digests and thinking, see, if I was going to do that, I'd use a Wii remote. And a Wii remote would track 4 infrared LEDs. If I put an infrared LED on top of each loco, for example, then the Wii remote would track 4 of them, and it would send their positions absolutely straight back to the laptop, which is controlling things. This is obviously an automation issue, not a general sort of using the layout type thing. And then, having thought about it a wee bit more, it occurred that if you put the infrared LED next to the Wii remote and just spray infrared light onto the layout from above, then you can get this infrared reflective tape. It's a bit dear, but you only need 1 centimetre of it. And you could happily track 4 items, let's say 4 locos, wherever they were in your layout, with the WiiRemote, which costs you a tenner, and one infrared LED that you stole off the front of the remote control. And people downstairs don't understand why the television doesn't work anymore, but that's another story. But it's a possible. And then I started thinking about it some more. Supposing that round about the layout, I was to leave constellations of 3 and 4 infrared LEDs. And at any one point in time, I illuminate a constellation of LEDs. Then if at that time, rolling stock has moved over the LEDs, then that constellation looks different. And by the fact that I've got the constellations mapped, I could say very, very simply and cheaply where my rolling stock is. So my totties simply become a 1mm hole in the baseboard with a 1mm infrared LED sticking up out of it. And these constellations, the WiiMote will quite happily do 100 Hertz. So I could cycle through these 50 times a second so that I could know where everything is to the nearest 50th of a second by switching on constellation 1 and checking it, switching on constellation 2 and checking it, all the way around however many constellations of 4 IR LEDs I've got. So there's lots of options there for using this very simple vision system to track stuff on the layout. This is the Host Shield library. And when you install the Host Shield library, you get the Host Shield library examples turn up in your examples folder on Arduino. And inside the examples for the Host Shield library, there's Xbox examples, there's USB MIDI controller examples, there's GPIO, there's using FTDI chips, there's all sorts of different controllers there. And if you go to the Bluetooth section, then there's things for Bluetooth HIDs, that's mouses and keyboards and stuff like that. There's PS3 Bluetooth, there's PS3 multi-controllers, there's SPP, I've got no idea what that even is. Underneath the yellow there, I think it's Xbox controllers. And then there's Wii balance board, Wii infrared camera, Wii multi-controllers. These are all Wii controllers. So all you need to do is go to that, select that, and up pops an example. So if I want a Wii camera example, for example, then I simply select that Wii camera example, up it pops, and I save it as something else and change the code to suit what I want to do. Use one of the output pins or check an input pin or do whatever I want. I simply add my little bit of code to the pre-written example. So I can be on air with a Wii example in 5 minutes. So to summarize, the WiiRemote is very, very cheap. It's very, very easy. It's very, very mature. There are lots of existing codes. There are lots of existing libraries. There are lots of possibilities. And there's lots of scope for undertaking serious investigation into how this could be integrated into your model railway environment. Any questions?